Hello and welcome everyone. We're glad you could join us for today's webinar on scanning to resilience, building integrated quality operations in the AI era. I'm excited to kick off this session and set the stage for what we'll explore together today. We're operating in a moment where AI can generate production-ready code in seconds, and attackers can identify and exploit weaknesses just as quickly. At the same time, many security and quality teams are still working through last quarter's backlog with disconnected tools and reactive processes. That gap between speed, quality, and security is just what today's conversation is all about. All right, so taking a look at today's agenda. Today we'll be covering the limitations of traditional AppSec and where that breaks down. Then looking at the number one DevSecOps capability, obfuscation. Then looking at integrated quality operations and how to bring teams together. Then also take a peek at how AI is reshaping the threat model and what that means for how we defend. And finally, we'll be hearing from you with our Q&A session. Now jumping over to our panel. Firstly, to introduce myself, I'm Hayley Menzies, the Product Marketing Manager at Sembi DevSecOps, and I'm joined today by Luca and John. So Luca Oniani is our product manager for the DevSecOps brands at Sembi, with over a decade of experience in software product management, healthcare, IT, and operations. Nice to have you on, Luca. And
Hello.
next, we have John Brunner. He is our solution architect for the DevSecOps brands at Sembi. He's over 20 years of experience across infrastructure, engineering, and technical leadership. His background spans .NET, Java, and the full software development lifecycle, which gives him a unique perspective that's equal parts builder and strategist. Welcome, John.
Thanks, Haley. Hi, Haley. Thanks, everyone, for joining today.
Excellent. All right, with that, let's kick off. So let's have a look at where security is today. So we know traditionally AppSec maturity has meant more scanning earlier in the life cycle, but attackers are increasingly target readable and modifiable code. At the same time, AI has accelerated both software delivery and reverse engineering, which brings us to a bigger question. What signals have you seen that suggests vulnerability scanning on its own is no longer enough for organizations?
Well, DevSecOps has had a bias towards AST scanning as a preventative. So we think more scanning earlier means more security. But really, there's a few signals and a few things that we see from the field that tell us that this might not be enough. What we're doing might not be enough in the app security space. And that comes in the form of signals from regulators. We've seen an increase in regulation, more regulation around building and deploying software. We've seen legislation fines, NIS2, DORA, GDPR continues to be relevant. FedRAMP is getting a new an update for the 2020s. This wouldn't really be happening if we kind of had things under control. Also, signals from folks like OWASP with the OWASP Top 10 and the MITRE Foundation, which gives us the CWE Top 25. So that we're curating and presenting the top 10, top 25 vulnerabilities that are in bespoke software that we're building. And these vulnerabilities haven't really changed over the past 20 to 25 years. If anything, they kind of shift position, but we're still dealing with SQL injection. We're still dealing with cross-site scripting. We're still dealing with insecure authentication and authorization. All these things are still in play today. They just kind of shift, so that they're still there, though. And we've also seen a record number of CVEs. That's common vulnerabilities and exposures. These are known software vulnerabilities that are reported to CVE.org, which is the industry standard. So in 2025, we had over 48,000 reported vulnerabilities. In 2024, that number was 40,000. In 2023, that number was 28,000. And that trend continues. And literally, if we go back 20 years, it's only continuing to go up, and it's spiked in the most recent years. And ultimately, this leads to an increase in the number of data breaches that we're seeing from these apps that we're building. So all this is to say, all these different signals tell us, well, whatever the security reality today is that an AppSec strategy that is focused on scanning isn't working. So these attacks are targeting readable, modifiable code. And we see how we're going to talk a little bit about how AI has accelerated the reverse engineering and things like that can be done. So we just need to kind of rethink how we're approaching application security now and in the future.
Absolutely. And thanks for that context, John. So it seems like there are plenty of signals out there, and with rising CVEs and breaches, let's talk about some of the limitations maybe of traditional AppSec. So we know scanning tools such as like SAST and SCA assume threats come from coding mistakes, but many modern attacks, as you covered, don't target the bugs. They exploit design exposures such as business logic, architecture, and embedded secrets. So containerized desktop, edge, and mobile apps all ship compiled code that can be reverse engineered. And that risk has always existed. However, now with AI powered analysis, reverse engineering is faster and easier than ever. So that said, we know AI is generating and shipping more code than ever. But if it introduces exposures that static analysis was never designed to detect, where does that leave us? And how should security leaders be thinking about this shift?
I'll take that one, Haley, because I have seen a lot of security professionals debating that right now on whatever the platform you go, whether that's LinkedIn, professional forums, or like other webinars. AI has changed a thing or two. The reality is that, like if you do it correctly, you can really get AI to produce code that is syntactically correct and functionally just fine. So when you run it through the security scanner, the code scanner, the results will be like all green, and the SaaS tool will be all thumbs up. But as you mentioned, exploits don't always target bugs. They don't always target mistakes in the code. Code that is technically clean and pristine can still be structurally exposed. It can be easy to reverse engineer. It can be easy to tamper with. It can be easy to harvest sensitive information from. And those are not the things a SaaS scanner helps you with. Like, scanning tells you if you wrote something wrong, but it does not protect what you ship. And whatever you ship in the wild, the binaries, they always become a target. So that is where code hardening comes in with its techniques and methodologies, including obfuscation, runtime self-protection. And that is the area where the security leaders are discussing the shift from, the traditional scan, fix, and ship to more modern scan, fix, but ship protected.
Yeah, that's super interesting. And then maybe carrying on from that, are there categories of risk where scanners are effectively blind by design?
Yeah, sadly, scanners are blind by design, and that's the right way to say it because, like, they are not broken, but they were not built for certain things. A SaaS tool will ask, is there a known bad pattern in the code I'm scanning? And if it flags something for you, you can go and fix it. But things like, can someone decompile my application and see my business logic? Can someone tamper with the binary after deployment? Can someone attach a debugger and step through everything? A scanner will never flag any of it because, like, it's not their job. So tampering and runtime integrity and reverse engineering as a whole, those are the themes where scanners don't operate, and not because they failed, but they were never designed to cover these areas.
Yeah, absolutely. Luca, earlier on you mentioned green scan results and the green scan results out of SAS scanners. So I'd love to hear from John here. In your experience, where do you see teams getting a false sense of security from green scan results?
Well, green scan results indicate that we've set quality and security gates in our pipelines, which we need. But if we have those green scans and they're in place and they're occurring, we might assume that our app is secure. It's totally secure. Thumbs up. No super high priority vulnerabilities been found, so we're good. But again, this doesn't take into account what happens once we've deployed those apps. So this, if something is happening at build time, that's one thing. But the second that we deploy into production, the second that the app gets into the hands of the end user, then there's that whole different set of issues that are potentially occurring, like Luca mentioned. You know, to reverse engineer it, decompile it, debug it, modify the software, create clones. All that stuff happens after you deploy it. So if we're relying solely on those green scan results, it's missing out on a full other part of the equation.
For sure. And then what assumptions do teams still make about that and server-side code and internal code? And why do you think those assumptions about that is breaking down today?
Yeah, so similar to the green scan results, like if you have code that's internal, so that is another assumption. And I've worked with teams, they make this assumption, oh well, my code's it's all server side code. I don't even have a client side. I don't have a client side, anything. It's all server side, which, well, is probably not true for one. You're at the very least, you're probably running in browser for one. But for two, it's what we think of as a traditional server side or internal code. If we're thinking not only it's fully safe, you know, it's behind my WAF, it's behind a firewall, it's internal, nobody can get to it. That's kind of breaking down for a handful of different reasons. For one, if you are a traditional SaaS company, there's been mounting pressure on SaaS vendors to create what's called what we call self-hosted offerings. So if I'm a bank, if I'm some type of vendor that requires strict compliance, I might not be able to send my data to some data center in Europe or the US that's not on-prem. So SaaS vendors have been forced to create self-hosted versions of their software. So the second you do that, take and package up and Dockerize your software, it's running in your end user's environment. And then once it runs in the end user environment, again, there's that risk of reverse engineering or tampering with or getting in and mucking about with which is your software. Second, even if you don't have a SaaS offering that has had to be turned into a self-hosted offering, there's been an increasing demand for what's called edge servers. So if it's a multi-tenanted system and all that computing power is going on in the cloud, well, that's caused issues with performance and whatnot. So the solution to that is to change the architecture of your software so much some of the server side functionality is pushed down to edge servers. So those services, instead of running in the cloud, they're running on your device. They're running on a server in your customer's environment. They're running on your mobile phone. So more of the server capability, instead of being run in the multi-tenant system, is shifted down to the customer. So that means that more of the functionality, more of the binaries, everything is sitting on machines that are not within your control as the vendor. So that traditional AppSec thought or idea of, hey, everything's it's in a server closet over there, I can point right to it. That's where everything is. That's not the case anymore for a number of reasons.
Yeah, absolutely. Actually, you mentioned something about the teams there, and we actually have a poll for the audience. And I'm curious to know from the audience, we'll put the poll up, is how aligned do you think your QA and security priorities are? So we'll pop that up and have a chat about that once we move on. All right, so we've heard how accessible reverse engineering has become, and the barrier to entry is lower than ever. Tools are widely available, as John's mentioned. So the real question isn't whether obfuscation belongs in your DevSecOps practice, but why it's not already there by default. With that in mind, a question for you, Luca. From your perspective, why do so many organizations still treat obfuscation as something that is mobile only, or is a last minute hardening step rather than a core part of secure development?
You have noticed that too, right? Um, well, um, well, let's be honest. That's just how many teams are structured. Sadly, most are reactive, not proactive. And honestly, I think that's also a perception problem or maybe a corporate inertia that has been there around for years, where security is often an afterthought. It also can be related to the cognitive bias, like the bad things will happen to someone else and not you. Someone else will be hacked, but not you. You will always be safe. You will always be young. That's even a term for this. It's called optimist bias or the illusion of invulnerability. So all of these assumptions lead people to limit the use of obfuscation and code hardening in general, and maybe use it narrowly only for mobile apps, maybe some financial applications because certain regulators require it, like PCI DSS. But as John said, the world has changed. You ship code almost everywhere nowadays. Cloud, edge, IoT, desktop, and whether it's an application or an AI agent, regardless the form of your deployment and the environment, there is always a chance that someone can get to your binary. And therefore, the attack surface is no longer just mobile anymore. However, that's the truth, that's the reality, and that is absolutely a thin ice everybody is walking on and can break at any time. That's what the threat actors are looking forward to.
Yeah, absolutely. And then I guess following up from that, what changes when obfuscation is then applied automatically and enforced in CI/CD instead of manually?
Mhm. Like, what changes? Everything changes, basically, and everything changes for good. Now, what happens when something is manual, whether it's a process or procedure or whatever? Something that is manual can get forgotten, can get skipped, or just basically can be done inconsistently. Someone leaves the team who used to do the code hardening, nobody remembers the step or doesn't even know how to use the tool. That's the risks of manual process. But when something is automated, it sits in the build pipeline. It runs, whether you want it or not. And if your build fails because security requirements were not met, you have to go and fix them. So automation makes security non-negotiable. It goes from like sometimes we do it to it's impossible to ship without it. So and that's a huge difference.
Yeah, absolutely. You spoke there a little bit about teams, Luca, which makes me wonder from a leadership perspective, how does one justify obfuscation to stakeholders who are then maybe conditioned only to think in CVEs or vulnerability counts?
That is a good point. Again, going back to, the sort of some of the biases we have around app security and understanding really from a stakeholder or maybe a higher management standpoint, everything comes down to budgets and money and things like that. So you have to be smart about um, how you use your resources. That's true. But one thing to understand, if I was going to try to justify this to a stakeholder who might not be as informed, is that CVEs are measuring vulnerabilities, but vulnerabilities are vulnerabilities that exist in code. But that's just potential energy, if you will. It exists, but what what actually matters is once we go into production. So these are vulnerabilities in code, but once we go into production, if we're only thinking about it in terms of the CVEs and vulnerability counts, that does nothing to take into account reverse engineering, debugging, unauthorized debugging, things like that. And that's where you get into things like stealing of IP and data, bypassing software checks, probing for vulnerabilities. All that can be done with the help of reverse engineering as a technique. We work with companies that have offered their software for 15 to 20 years. Well, that's intellectual property. You know, Coca-Cola wouldn't want the secret for Coca-Cola getting out. KFC wouldn't want the secret for their secret recipe getting out. And similarly, if you're building software that has some legacy behind it, there is some intellectual property built into it. Aside from that, let's say you don't care about your intellectual property. There is still the risk of pirating the software, spoofing, cloning, repackaging attack. All of this could hurt revenue. Real life example, we had a customer come to us after the fact. They had an app that they were building and deploying to the Play Store at the time. This is going back a ways, but they had this app that was had like motivational like sayings and expressions and stuff like that, and somebody ended up decompiling, reverse engineering, cloning their app, and creating a spoofed copy of their app, which was injected up with all kinds of ads and app malware and all sorts of things. And this is something that happened that really caused a lot of damage to that organization. Unfortunately, they didn't come to us first. Had they come to us first, we could have helped them with that. So, long story short, adding obfuscation as a first class DevSecOps capability, it's protecting against reverse engineering, which is a material risk to the business, to revenue, and customer data. That's the bottom line.
Absolutely. And folks, we've still got a poll going, so we'd love to hear from you as we move on, and appreciate that context there, John. It was really good, and especially around the material business risk, which is often what we see QA, security, and application protection teams operating in silos and each optimizing for their own outcomes. And often when those teams aren't aligned, blind spots emerge. And so organizations that are getting this right have probably made one important shift. They test protected builds and not just the source code. Based on some research done by SEMBI, surveying nearly 4,000 professionals, about 66% of QA and security teams report only moderate or weak alignment in their priorities, which lines up pretty closely with the results from the poll just shared earlier in this session. So here's the challenge I see. This doesn't really sound like a tooling gap, but maybe a culture gap instead. So what does that look like in practice, and where do things typically break down?
You're right. It is not necessarily just around tooling. Tooling can help, but you're right. It is a cultural thing, and a culture within the organization. That is to say, it's just teams just not talking to each other. And there is the QE team is concerned about percentage of code coverage and percentage of tests passed before we go to production. The app security team is concerned about the percentage of binaries we have obfuscated, and the amount of renaming applied, and the amount of tamper detection, make sure the correct binaries have those applied. So that's we're optimizing for different metrics, and we're judged on different metrics, and that will impact. Everybody's busy, nobody has a lot of time, but that's the bottom line. So people, they get myopic, and they can't really focus on everything. That's understandable. But the problem is if we don't even make a small effort to connect those teams and have some communication, then what ends up happening is QA does all its testing, make sure everything looks good, performance testing, functional testing, load testing, whatever testing we're doing, that looks good. But then if security binary hardening is applied as a later step, what ends up happening is we've done none testing, we've done zero testing, or we've done not enough testing on the binaries that are actually going to the customers. And then what happens there? Well, we get this code in our hand. Okay, well, because we didn't even think about it, all of a sudden we have performance issues that are showing up in production. All of a sudden we have potential bugs. Wait, why is there this deserialization issue? Well, because we didn't test the protected binaries. And ultimately, who's going to find that? Well, the customers are going to find that, and it's going to come in through technical support, and it's going to cause other type of issues that have nothing to do with um, uh, our jobs as QE and our jobs as security people, like applying security. That's a totally different thing. It's totally out of left field, but the customers will find it, and they'll pay the price, and that's going to cost us as a
Absolutely.
business.
Some really big consequences there. And John, like, what's the most common integration mistake when you see when teams are trying to add that in really late, that protection?
Well, if we're trying to do it a little too late in the game, then we probably realistically will not have enough time to really think through what we're protecting and why. Ultimately, adding obfuscation, adding risk, or adding RASP, runtime application self-protection, the tamper detection, the debug detection. Ultimately, that's about mitigating risk, mitigating those business risks. And if we're not thinking about it from a risk stance, then we're probably not going to add enough obfuscation. We're going to add too much obfuscation. We're going to add the wrong transforms because we haven't thought about it. Does control flow make sense in this context? Does tamper detection make sense in this context? No. Well, root detection or jailbreak detection, that only really makes sense to a mobile app. DevTools blocking, that only makes sense to a browser. But you have to think about that. And if you're trying to do this late in the game, you probably can't think through some of those finer points. And then again, not only are we not protecting enough or are we protecting too much, we still have to think about performance issues and things like that. And we also have to think about our CI/CD. Like nowadays, CI/CD is getting more and more complex. There's more things in our pipelines. And so we can't, if we're trying to do this late in the game, well, if we have enough time to think about our pipelines and our YAML files and stuff like that, then we can plug it in the appropriate location so that we just, boom, kick off our build, all the steps happen, and then we can deploy it. But if not, and we're trying to build manually or on the command line, well, what about the signing step? What about our publish step that goes to 2 to 3 different places? And that's all built into our automation. Well, if we do this late in the game, we will not have time to make sure this lines up with our automation. That does take some time too. But just in general, adding any new tooling or updates to tooling or process late in the game is a bad idea. And all that would be prevented if we just had some communication between dev, QA, security, just a little bit. So
Absolutely.
not too
And
late.
how, like, appreciate that, John. And how could scanners make better decisions than if they were to understand those runtime checks that are in place or runtime protections that are already in place?
Well, that's pretty practical one. Right now, as John already spoke about the disconnect among the departments. So if people are disconnected, tools become disconnected as well. So even and today, scanners and runtime protection live in separate worlds because of the pretty incorrect assumptions that we mentioned earlier. But there, if you fix this culture, there can be a human orchestrator that can have all of these coordinated. And so let's take a practical example. Imagine if a scanner knew that this or that function is already protected with the, let's say, tamper detection, or it's obfuscated, so it cannot be easily found. Then maybe it does not scream about all these low risk findings here and there. And this will enable you to concentrate your energy on the parts of your code that is more prone to exposure. So this helps you to avoid noise This helps you navigate the complexity of your software development and helps you with better prioritization. And obviously, with better prioritization, you get better releases. This is what we call context-aware security. And this, with this, you just stay focused on important things and ship protected applications without slowing down.
Absolutely. I really like that term, Luca, context-aware security. I'm curious, do you see like a future where vulnerability severity is then contextual and then not absolute as it is today?
100%. And honestly, it should already be like that. But if it's not, we should be marching toward that goal. Severity of a security finding should depend on factors like um, is the code exposed to the internet? Is it obfuscated? Does it have runtime protection applied to it? Is it handling sensitive data? Because, a vulnerability that is compensated by a fail-safe mechanism is a different kind of risk than the same vulnerability in a completely unprotected raw binary that can be reverse engineered in minutes, especially with AI assisted reverse engineering.
Looking at building integrated quality operations, so as organizations are scaling and automating more of their delivery pipeline, we saw from the previous topic and the survey that quality can't just live within a single team or tool anymore. It really has to be integrated across teams to be able to be successful within the business. And with that in mind, like, what does successful integrated quality operations look like inside modern organizations? Maybe this is a good one for you, John.
Yeah, I appreciate the question, and that's really the main thing we've come to talk about actually is what is integrated quality operations. And so, you know, we work with different organizations of different size, organizations with different responsibilities. We work with organizations that have a ratio of 60 to 1 developers to security people, or all the way up to 400 to 1 ratio of security to developers. We work with companies that have, very sophisticated, very mature AppSec organizations and cybersecurity teams, red team, blue team. They have their own internal SOC, all that stuff. And we have organizations with really nothing to speak of. So how would you make something like this happen, regardless of the size of your organization, regardless of the maturity of what you have in place? Well, there are a couple of characteristics that would really make it work. First is that everyone sees the same data. So there is the ability to see whether it's QA-based metrics, security metrics, velocity, everybody's able to see the same data. There's not segregated data here, there, everywhere based on team. The critical data with respect to delivering software, everybody sees the same data. The tools talk to each other in some respect. So, where would we be if, like, for example, if support team is using Zendesk, the dev team's using Jira, well, we have to have some connection between the two. And the same goes with our QA tooling and our security tooling. The protection's planned early, and it's not at or release near release time. So we're thinking about security throughout the process and shifting left as much as possible. And with security, again, we have responsible parties, but security is shared. So we're sharing our OKRs, we're sharing KPIs, and we're sharing it across the team. So the bottom line is, when it comes to application security, securing your organization, cybersecurity, all that stuff, we need responsible parties. So if a website starts acting funny at 2 a.m. on a Saturday, we need to know who we're calling. So we need to know that in advance. But we also share the responsibilities as far as making sure that the software we're delivering is not only quality software, but it's secure. So those couple of characteristics that I've laid out are, I would say, the key characteristics of organizations that are practicing integrated quality operations. Now, here at Sembi, we do a lot of work to connect QA and security. We have with TestRail, who is our partner in Sembi. We've built and TestRail is a leading test management platform. So we've built an observability layer. So right from TestRail, whether you are a QA person, whether you're a security person, this connects QA and security for overall release readiness, because we believe release readiness is not just, hey, if we pass all our tests, hey, our pipeline's working. It's no, we have to security, quality, all of the features that we want, everything is done. That represents release readiness. So we've done a lot of work around building that observability layer. So if practically speaking, if I'm a QA person and I go into my TestRail instance, I can see my test suite, my test cases, and I can also have side-by-side mapping of these are all the vulnerabilities that have been found in the code. And that's what the integration gives us. And so as we're doing our testing, we can say, oh, okay, well, we know that within our authentication mechanism, there might be a SQL, some type of injection vulnerability. So we can craft tests, not only craft tests around that, but we can also make sure that we build that in our day-to-day. And then on the other side of that, with preemptive, we can know that we've actually protected the appropriate sections of code and applications that we need to apply protection to. So we have that visibility. We've built that into our test trail. And so, yeah, as far as tooling, getting tooling, we're working a lot on the tooling side. But those other things that I mentioned are really more process and organization and culture, building it into the culture. So
We know AI has dramatically lowered skill barriers for reverse engineering. LLMs can explain decompiled code, trace logic flaws, and suggest exploit paths in minutes. So defense must assume that attackers both have the automation and intelligence needed. As a result, like obfuscation, scanning, and testing must evolve together, as we've seen. And there's no permanent fix, right? Application protection requires the same continuous improvement mindset that you bring to the rest of your DevSecOps operations. So your protection strategy should probably also keep pace. How does AI change then what good enough obfuscation looks like today?
Well, AI, raised the bar. And what was good enough 2 years ago is not good enough today. Today, with this reality that we are dealing with, obfuscation needs to be deeper and layered, more layered, because free, simple renaming utility that you found on your own somewhere in the internet won't save you anymore, especially against AI-assisted reverse engineering. So seriously, you need to harden your code by combining different techniques like string encryption and control flow obfuscation. You also need to extensively apply runtime checks. This is necessary, for what? You need to ensure your code at rest is protected, but you also need your code at runtime to be protected. So with AI around and with the bad guys being really, really good at using AI when it comes to exploiting applications, you should also always review and revise and update your security strategy, update your recipe of obfuscation and code hardening configuration, because they can get outdated pretty quickly. You need to follow the pace, follow the trend, follow the tendencies, and always assume that the attackers have time, they are smart, and they have tools.
Yeah, absolutely. It's a really, really good piece of advice there, Luca. Maybe John, over to you. If you could look into your crystal ball in a few years, what capabilities will then define a mature AppSec platform given this AI first development world that we're in and will continue to
Uh,
be driving into?
yeah, yeah. Well, no, yeah, this is a good point. Is agentic AI will continue to represent a higher percentage of the code, overall code that is produced and sent. It's just going to keep, Copilot and Claude, stuff like that. It's only going to increase. We will also have agentic security agents and auto remediation. All that stuff will come out. But ultimately, a mature AppSec program in the AI world, regardless of where we're at tooling wise, we will have ways of finding flaws, protecting code, automating the enforcement, and connecting the teams without slowing delivery. So people process tooling is still and will always be valid. Defense in depth will always be valid. But the bottom line is that we have teams connected and we have good communication across teams.
Yeah, perfect. Just being mindful of time, we're almost up. So looking to wrap this up, in 2026, organizations getting this right, as we've heard, aren't the ones that are treating these things as separate problems, so quality, security, runtime, resilience, all with one integrated outcome and not three separate to-do lists. Which brings me to a final question. Whoopsies. Which brings me to a final question for both of you today. John and Luca, if there's one thing or one key piece of advice you'd like the audience to take away today, is how would you get better security without sacrificing that delivery speed? One piece of advice.
That's really hard to limit the answer to just one, but if I had to do that, then I would say, update the mental model and stop assuming that if the scanner is green, you're safe. No, no, no. Applications and the organizations that build those applications are being attacked and hacked right now as we speak. So my piece of advice, if it's just one, would be add code hardening and techniques and methodology to your security strategy. Not instead of scanning. Nothing wrong with scanning. Just add it next to it because scanning alone is just half the picture.
Absolutely. John, any
Yeah.
any last pieces of advice?
Well, yeah, just to build off of what Luca said, so if you don't have protection, get some form of runtime protection and hardening in place. But if you do have protection, so hopefully you do, uh, automate it and add it to your CI/CD. And number two, for bonus points, make sure you're testing those protected builds. That's as simple as that. Without having to build anything elaborate into your processes, just make sure you take that additional step of testing automated builds to make sure you verify. Otherwise, your customers will find those issues. So that would be it.
Perfect. We're running almost to time, so appreciate it. We've got some questions that have come in the Q&A panel. Audience, if you've got anything burning desire, please ask us. One of them I've already answered. It's just about the SEMBI research, but maybe I'll pick this one, and whether John or Luca, you can take it. Where should teams start if they can't protect everything at once?
That's a great question. So we would back it up, and everything always goes back. Still, this day, everything always goes back to risk and our threat model. So, well, if you haven't done a risk assessment, do a risk assessment. If you haven't done a threat model, do a threat model. You can even be on a whiteboard or something. It doesn't have to be elaborate, but from there, everything will flow. So once you have established your risk profile and you know what your threat model looks like, then you can start determining what needs protection. because you can't just go like a bull in China shop, just do everything at once. That's just going to be too much. So once you've done your threat modeling, you can say, okay, this is closest to the threat edge. Yesterday, I need protection going on this. That's assuming that you're in that, you find yourself in that position where you need to get started. But yeah, I would just say everything should flow from your threat model. And then you can look at things like, well, this one handles some pretty sensitive data and it's pretty high volume, so we need to attack that one first, and then go from there.
Yeah, absolutely. Um, Moving on, we've got another one here. It's saying what metrics actually prove obfuscation is working?
That is a really good question, actually. So whoever asked that question, thank you. Because it's one of those like, well, we're protected, right? Well, no, we need to put that into numbers, and the higher ups want to see numbers. They want to see metrics. So I would focus on metrics like overall obfuscation. So at the end of obfuscation, for preemptive at least, we provide reports. This is where tamper was applied. This is the percentage of renaming, things like that. We would look at things like that. And if we're seeing a low percentage of renaming, or we don't have the right number of binaries added to obfuscation, we would want to address that. That's just addressing it practically. And then from a more just overall standpoint, we would want to look at things like any runtime overhead statistics. So if the binary size has increased and memory usage or execution times are outside of any sort of accepted performance numbers, and it needs to stay performant. That's the other kind of side of the equation, but those are actual hard numbers. And then we have more like qualitative metrics. So actually, how easy is it to reverse engineer? We got an API key. It's embedded within the binary. How easy is it to take out of this DLL after we've had obfuscation applied? So we have no obfuscation applied, and we have obfuscation applied. But that's more of a qualitative metric. Might even be a little bit harder to reflect in whatever sort of reports we build out and present to our management. But yeah, I would say those handful of things.
Yeah, perfect. Just being mindful of time, we've got a few more questions coming in. Another one here is asking, how do you build integrated quality operations when you are also reliant on utilizing third-party suppliers for elements of your business whom apparently do not have a sandbox environments that can be used to mimic behavior?
Oh, yeah, actually, that's a really good question because that's the reality of the world that we live in today. Our software team and teams are not all in-house. They're not sitting across the room from us. So it's valid. But what I would say about that is when we talked a little bit earlier in this discussion about establishing responsible parties. So while we're all working together, the buck stops with one person, and they're responsible for what these other functions will do. And a lot of times we rely on pen testers. Even for us, we rely on external pen testers. We rely on SOC teams and managed security service providers, MSSPs. These are not within our organization. But at the end of the day, somebody is responsible for them and keeping an eye on them and making sure that they do act as a member of our own business. Because at the end of the day, we need to make sure that whatever their interests are, they align with ours. And it's not just, they do whatever they want to. So even though they are third party, there is somehow a communication channel between us and them. And that needs to start with the person who's responsible for overseeing that. And then once that person or persons has that communication, they need to make sure that they have strong communications. And then also that where applicable, the broader team has communications with that third party vendor. Because you're right, that it happens. You might work with a different developer partner, that relationship breaks down, but it all comes down to who's responsible for this third party vendor and how are you maintaining that communication. Once you do that, once you establish that, then you can build from that. You always establish a baseline and then build from there. So hopefully that answered the question. It's a bit of a esoteric one, but hopefully I answered it.
It's amazing. Thanks for that response, John, and hopefully that did answer the question. Another couple, we probably take one more and then we'll probably have to wrap up. So, what major security trends do both of you observe among your clients before and after deployment? And before you guys chime in, it's an interesting one because this was actually something that was surveyed in the SEMBI survey that I mentioned. It hit almost 4,000 professionals. So keep an eye out because it might be really nicely timed. This question, the security trends that professionals are seeing before and after their deployment. But I'll hand it over to one of you guys. So, what major security trends do both of you observe, or both of you observe among your clients before and after deployment?
Luca, did you? I feel like I'm just like I don't want to feel like I'm taking your opportunities, Luca. So feel free to chime in and if you want.
Go ahead. Go ahead. Go ahead.
Okay. All right. All right. Well, you know what? I might actually cheat because I see there's only two questions left in our chat, and I think I can answer them both with one fell swoop. So do you mind, Haley? I don't
Yeah,
want to, but
absolutely. I mean, the other
there's two questions,
question, yeah, the other question is,
yeah,
I
and it's a
don't know
good
if I
one
can
too.
do two, but it says, how is SMB currently adapting to fast-moving trends like AI, where innovation evolves quickly and quality needs to evolve even faster? So it's our final questions for today.
So yeah, I wanted to answer them both because I saw them come through. They're both really, really good questions. Number one, there's, there's a reason why you go to a vendor and you don't roll your own crypto. It's because there are always decompilers, disassemblers. It's always a cat and mouse game. AI notwithstanding, there is always the threat of hackers trying to do fancy new things. AI is nothing new. It's always the case that this is a fast moving space. So while the question is about AI, it's more about the cat and mouse nature of application security. So what I would say to that is this is why you come to a vendor. We do at Sembi, we're doing a lot in the AI space to roll out new features and functionality across all our brands. So it's fun, it's challenging, but yes, it's nothing new. And then trends among our clients before and after deployment. So, I mean, that's a rather broad question, but I would say a lot of it is, again, it cuts across many different dimensions, but we work with teams that are super mature and they still don't have this communication across teams. So we find out issues come into production, and hey, we put this app out into production, and lo and behold, they didn't apply enough obfuscation, or there's performance issues. That's not an issue with the tooling as much as it is, hey, we did not have that communication across our teams prior to going into production because everybody's moving so fast. So. Yeah, and I'm not sure real quick, Luca, if you had any additional thoughts on that, but I mean, I would say that that's pretty much how I
Amazing.
think about that.
Yeah. Well, Luca, unless you want to chime in, we're probably right on time. Um, but yeah, really, really great session today. Really enjoyed that discussion, Luca and John. I really appreciate it. And of course, thanks to all of you for submitting your questions. I think that was really awesome. Before we wrap up, just a reminder, we'll be sending a follow-up email within a few days with the webinar recording, including the Q&A. And if you do have any other questions, please get in touch. And some resources for you to get started with us at SMB if you're not already. And with that, thanks for spending your Tuesday with us, and we hope to see you again soon. Bye for now. Thanks, John. Thanks, Luca.